Hello friends, welcome again to Go Tutorials. In this section, we are going to see the balance of the previous tutorial session. We had seen slices, arrays, everything. So the slices is having some more things we need to explore. That is what we are going to cover in today's session. It's going to be a smaller session comparing to others. Let us see what it has in store. Right. So, as we discussed earlier, we can create slices. Slices are nothing but an abstraction layer over arrays, which can offer some dynamic functionalities like adding some values, removing some values over the existing static arrays. So, the main difference between array and slice declaration is the size. So, within the square brackets, if you mention a size value, it will be considered as an array. If you skip the size values and simply leave the square bracket as it is, then it will be declared as a slice. And also we have seen what is a length of a slice and what is the capacity. So length is nothing but the number of values inside the slice. Capacity is the size or the maximum available number of slots in the underlying array or underlying slice. So that's all about the things we have seen in the previous presentation. Now we are going to see how to append values to the slice. Was the main agenda for today's session. Right. Let us open the command prompt, maximize the screen. I am going to go demo Pico, opening my favorite editor for the name slicedemo.go package main import fmt function main. As usual, it is a very simple program I started with. Perfect. Now, as we discussed, creating a slice of type string with some set of values 1, 2, 3. Perfect. Format.Printf. The length of names is %d. Capacity of names is %d. Len of names, similarly cap of names. So we are done with the simple code. I am running this. Go run slice demo. So we got the answer as length of names is 3 and capacity of names is 3. Both looks alike, of course, because we have only 3 values in the slice mentioned. So by the number of values we have initialized, the compiler understood the names slice is having length and capacity both equal to 3. Interesting. Now, what I am going to do, I am going to do something new. What it will be. So what I am now thinking is, I am planning to add some more names to the existing slice. So what I can do for this, there is a function called append. We can use the append function. This function carries 2 arguments to which slice I am going to add values. Names is the slice I am interested with. So what I am going to add? I am going to add a string 4. So I need to assign the response to the same variable names back. So what I am doing, I am creating one more slice by extending the existing slice and assigning it back to it. So append of names comma 4. I am assigning that particular response to names back. Now I am trying to print the length and capacity. Let us see what happens. See here, the length of name is 4 and capacity of names is 6, which is quite interesting. Length of names is 4, of course, because already we have 3 values. The length is also 3. We are adding one more value here. So automatically the value will be 3 plus 1 and the length is printing it as 4. So which is correct. It makes sense and logical, right? But the something called capacity is showing 6. which is totally unexpected and nowhere it is relevant to the number of values. So why the capacity is being shown as 6 for this names slice? Because earlier while we declare here both length and capacity is 3, because we have not mentioned any capacity. The length of the slice is 3, so automatically the capacity is also 3. Now here we are adding one more value to the slice, so the length is 4. So far it is good. Even I have not mentioned any capacity. The capacity also should be 4. Why it is 6? That's where comes the capacity handler in Go. What does the capacity handler does is, whenever we use a append command to increase the capacity of an existing slice, the Go compiler will double the slice of the capacity. It will double the capacity size of the previous capacity. Earlier in this particular line, the capacity is 3. Now we are adding one more value, so the capacity value dot doubled. Now 6. That's why the reason we can see if you add a value, it got doubled up. Right. So to check this further and confirm, what I am going to do, I am going to add 4 here. Now I am going to add 5 here. So what will be the value here? Length and capacity is now 4. Here what I am telling, I am adding one more value to the slice where the length is 5. So far so good. But now what my assumption is, the Go compiler by default the slice value or the slice length or the slice capacity for the variable names is 4. Now I am trying to add one more value to the length, so that the capacity will also get doubled. Now the capacity should be 8 instead of 6, because the capacity earlier is 4. Now by the virtue of adding or appending a new value, I am asking the Go compiler to extend the capacity. The Go compiler will extend the capacity only by doubling its size. Now I am going to run the code. See here, the length of names is 5 and capacity of names is 8. So this is how Go compiler internally handles the capacity of a slice. So it needs to be noted, whenever we keep on appending values, the length will increase accordingly, whereas the capacity will get doubled from its size. It is one of the key takeaway points for Go capacity handling. Right. So now the capacity value is 8. So it is a very simple code where we added using one append statement, we have included a value to the slice. Right. Now what we are interested is, we are going to add a slice with another slice. What we are going to do is, already we have seen appending values to a slice. Now append to a slice from a slice. So what I'm going to do, I will take some set of value. I'm going to have two slices. From one slice to another slice, I append both of them. Let us see how to append both two slices. Pico append slicedemo.go, same package main, import fmt function main. Within this function main, what I am planning to do is, I am going to declare an integer slice. I'm going to name it as x colon equal to bracket integer, right? So here in this integer slice, what I am planning to add some values like 10 comma 20. It is as simple. Okay, let us keep three values. Yeah. So 10, 20, 30, and for y, oops, yeah. Similarly, integer 40, 50, 60. So we have created two slices so far. Now what I am planning to do is, I am going to append both the slices. So how do we append the slices? Using the same append statement, we are going to append these two. So I am using format.Println. What is my append statement? append x comma y. So this looks a very similar or very easy statement, but it is syntactically wrong. we cannot provide two slices as an argument for the append statement. We need to tell the Go compiler explicitly that one value of slice should copy all the elements from another slice to one slice to another. For example, the value from slice y, all the slice values to be copied to the x slice, so that the values from x and y both needs to be copied fully. For that, what we need to do is we need to include the dot 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 operator. Consider what I am doing is without the dot 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 operator, I am going to compile the code. Go run append slice demo. See here, cannot use y as type int in append because it is an integer slice. I cannot use it as a direct integer. So in order to use or consider it as a slice, what I need to do, I need to fetch all the elements of the slice and append it with another slice. For that, to fetch all the elements, I need to use this operator dot dot dot. Now if I save and run the code, you can see 10, 20, 30, 40, 50, 60. All the values from both the slices were got appended and displayed it here. So here values from both the slices were appended here. So this is where the statement where we need to how we need to append to different slices. Right. This is a very simple code, so we are able to achieve how to append the slices. Right. So we are done with the second concept, appending to a slice. Next one is iterating the slice. Right. So already we have seen some ways to iterate over the slice. So already we know a for loop where we declare for I equal to 0, sorry, I equal to 0, I less than length of x, I plus plus. We used to declare like this, and here in this for loop what we will do, format.Println, we used to print x of I. So this will print all the values inside the slice x, which is 10, 20 and 30. So now using the conventional or traditional for loop, we can iterate all the way inside a slice to fetch the values. This is one of the ways. Now there is one more special type of for loop construct offered in Go programming language to iterate with collections such as arrays, slices or maps, etc. This is called for range loop. So we are going to see something called for range loop. So what is that for range loop? Earlier here in the above statement, we have iterated the slice x with the conventional or traditional for loop using the numbers. I equal to 0, I less than x, I plus plus the same way. Now what we are going to do, we are going to iterate the slice y and print the values using the for range loop. So how to iterate using for range loop? This is what now we are going to see, right? So what is the syntax? The syntax is for, as usual. The next one is the variable needs to be iterated. The variable is I. This is going to be the index. It is as usual for I, but I am not going to initialize I with any of the values here. It is a kind of a, instead of for range loop, I can mention it as for each loop. So in other languages like Java and all, there is a thing called for each loop, which is used to iterate the collections. The same way the for range loop behaves here to iterate with the collections. So I is the iterative variable which I will use to iterate over the collection. Okay, and the value that needs to be fetched for each is will be in the variable. I am mentioning it as value. I need to separate them with comma. So the first argument is the iterative variable or the index or whatever you feel. The next variable is the value itself. The value itself from the list. So how to take the list? So what we need to do, we need to assign the value as range. So from where the ranges needs to be taken from. So the ranges needs to be taken from y. So this is this for loop which I am interested with. So what does its for loop means? Here, what does it means? I is the index for the iterative for loop Y is the collection or slice with a range of values, and value is the control variable to hold iterative values. So what I am going to do now, I am going to print format.Println value. It is as simple as this. I am going to print value. Sorry. And I need to print it. So let us use printf. Index is %d and value is %d. Yeah, let us print like this. That will be easier for us to understand. Okay, I comma value. So this is what we are trying to say, right? So I is not that much meaningful. So let us use the variable index. Okay, I itself is enough, I suppose. Yeah. Yep. See here, index is 0, value is 40. Index is 1, value is 50. Index is 2, value is 60. So see the code here. I is the index for the array. So when the I value is 0, that is the index is 0, the value which is being fetched from the range. A range is nothing but a set of value taken from the slice or collection. So range y means the set of values from y. So from the set of values from y, this particular indexed value is assigned to this variable here. So here it is, the value is the variable which holds the ith value of this slice. So I can put it in this way. Value is the variable which can hold or contain the ith value from slice y. This is the meaning of this particular loop. So for I comma value, I is nothing but the index where I is the index of iterative for loop. Right. So here I is the index for which the value 0, I am fetching the value from the range y, which is nothing but the slice y. So the 0th index 40 will be assigned to the variable value. So that is printed as 0 comma 40. Now the iteration is getting to the next location where the I value got incremented internally. So we are not manually doing any increment or decrement operations here. Go compiler internally takes care of doing the increment when we deal with the range. So whenever the Go compiler sees a for range loop, it will create a control variable and it will keep on increment or decrement the variable as per the range specified. So this is how we need to use the for loop structures using for range loop, right? So here, whenever we use this for range loop, we have two things mentioned. The first thing is the index, another one is the value, which is nothing but the range of y. So from the range, the value will be fetched and it will be printed, right? But even though the index is fetched, but I am not interested to display the index. That's what I did earlier, but I landed up with error because I am not interested to print the index. What I need to do, so I can omit I don't need I. So what will happen here? So I can ignore the index. I just need the value only. If I compile the code, the same error will pop up because I is declared and not used. But I am not at all interested with I. I don't want to do anything with the index now. So for that, what I need to do? I declared a variable, but I am not at all interested with the variable. But Go compiler is forcing me to use all the declarations. For that, already we have seen one special operator using which we can skip the variable declarations. That operator is underscore. So I can use the underscore. So using the underscore is nothing but a blank identifier. So using the blank identifier, I inform the Go compiler I am not interested with this particular variable. Here the blank identifier is placed in the place of index. So that means for this for range loop, I am not interested with the index. So the Go compiler will not compile me on skipping the index to be printed. So the code I am executing is running here. Value is 40, 50 or 60. So I can use blank identifier to skip up any of the mandatory variable specifications. So this is just for you to note. Blank identifier can be used as efficiently whenever there is a need for a variable to be declared and we may skip the variable. Those areas we can use blank identifiers. Okay, so there is nothing wrong having the identifier here for me. So I'm just adding I. So I need to print the index as well. Index of index value is percentage %d. And then for the first percentage %d, we need to print I. Index value is 0, value is 40. Perfect. Index is 0. Yeah. So this is how we can use for loop to iterate the slices. So we have two ways to iterate the slices. One is to use the conventional for loops using I equal to 0, I less than the length I plus plus. Another one is using for range loops, using which the index and values we can use as an iterative parameters in for each or for range loop. Okay, so similar to this, we can use multi-dimensional slices as well. So we have seen two-dimensional arrays, right, in the previous one of the previous video sessions. Similar to this, we can have two-dimensional slices as well. But only one change is we are not supposed to mention the size anywhere. So when we declare two-dimensional slice, we just need to add one more open close square bracket and we need to nest it with the brace inside. It is as usual we used to do in the arrays. The same way we need to follow for multi-dimensional slices, but the only rule is we are not supposed to mention any size in any of the square brackets. So that is the only major difference in using multi-dimensional slices. Apart from multi-dimensional slices, there are a concept called passing slices to functions. So how do we pass the arrays to functions? The same way. Already we have seen in previous examples, we used to pass arrays to functions so that the declarative array data type and to the function where we are passing the data type both should be the same, and also size should be same in both the functions as well as from the calling area. But in slices, while passing slices from main to other function or one function to another function, there is no need to worry about slice size because we don't mention any size for the slices. We just need to ensure both the slices, that is the slice which is getting passed and the variable from where we are receiving the slice value both belongs to the same data type. We just need to ensure this particular thing, but otherwise syntactically both are one and the same. Please check the arrays tutorials where we have seen passing arrays to functions. The same way we can pass slices to functions as well. So this concludes our entire topic of slices, and this is the second part of the slice presentation. So we are ending slices concept with this particular presentation. From the next presentation onwards, we will see a new topic from the Go programming language. So please add the comments or raise your queries or anything in the below comment section. Don't forget to click the subscribe button. Also, please remember, whenever you click the bell button, you will get updates whenever I upload a video. Thanks for your support. Let us catch up in the next video session.